in the common name library, we talk a lot in NDN about it's not about a communication channel, it's about the names. And so we wanted to try to create a kind of higher level interface above simple interest data exchange, which really embraces that. You've seen a couple slides where, for example, Jeff Burke showed the namespace for the AR application, or Peter showed the namespace for NDN RTC. That's really the first step that you're doing when you're engineering an NDN application. So we wanted to, and the idea is you have different collections of data under a name prefix, for example, keyframes or certificate trust, and so we wanted to directly embrace this idea of collections. Some of the lower level libraries still have lower level primitives like express an interest or prepare to receive data, or other people have made APIs which try to look like a TCP socket, a socket interface. We wanted to take a different approach so that the primary interface was the namespace, not a communication channel. And we also wanted a place where the application could work in an extremely asynchronous environment, where you don't know when an event's going to happen. You don't know when you're going to receive a piece of information or need to create one. And we also wanted to create a general namespace support. If you have a simple socket API, it'll try to push the details of signing and verifying things kind of out of your way. But the truth is, in a sophisticated application, under one of the namespaces, you might have one data signing policy or verification. Another part of the namespace, you might have a different one. Or as Alex just pointed out, with when you want to encrypt, you might need under one part of the namespace to get the encryption keys in one way and another part in a different way. So we wanted to create an infrastructure where all that could be specified by the application. Also, there's common naming patterns. We have, like, for example, sometimes we segment a large piece of data into smaller segments. Or you might have versioning based on sequence numbers, or you might have versioning based on timestamping. And we wanted to create a way so the application can give specify a certain handler. Under this namespace, I do versioning based on timestamps, and then let the library to try to take care of the details for you. Finally, Spiros talked about a way of retrieving the latest piece of data, but in general, we talk a lot about the namespace, and the biggest idea is if different people in the application can simply have a way of syncing up the names, and we were to provide a lower level protocol, then if everybody in their application can look at their internal representation of the namespace, then you could just look at the namespace and see what the latest version is. So we want to have a way of playing with the different ways of doing that syncing. And I already talked about trying to give a more general way of doing consumer producer or real-time data retrieval. And I'll show you this a little bit later, but there's multiple ways of producing a data packet. In other words, if I get an interest for it, maybe I already have it stored on my hard drive, or maybe I need to actually produce it and sign it, or maybe I need to retrieve it from somewhere else and serve it. And so we wanted to integrate a way of handling all these different possibilities. Likewise, right now we have a really simple way of asking for a piece of data, which is you can ask for the prefix, right? And a lot of people ask us right away, okay, I have a name, and maybe I have the name which says, UCLA Jeff, and I might want to retrieve, papers. but there's a middle name component, which might be, year or something like that, and I want to skip that. I want to find out papers, but I don't care what year. So you might want a wildcard there. You imagine if you're typing an LS query with the slashes, and you want to put a star in one place. If you have your own image of the namespace already in memory, then you can use all kinds of ways of searching the namespace for the name you want, like regex expressions or wildcard to skip. And I'm going to talk more about the data generation in the next slide. So that's the motivation. Here's a code sample just to get started. The idea is there's a class called namespace, and that's an object of that class is what you use at each node, and you represent the namespace hierarchy just like you saw, and you have parents and children. Anybody here ever used your HTML in the browser and you wrote a little piece of JavaScript to walk the DOM? Anybody know what I mean by walking the DOM? Only 2 people. Likewise, have you ever written a user interface like in Java, and you have like the window, and then you have a panel, and then you have a button, and then so there's both of those systems they took that approach because it's purely asynchronous. And in a sophisticated HTML application, the JavaScript is dealing with this document object model, which has like page and then an element for a region, and then it has an element for a button, and then it has an element for the text inside the button. And you deal with it by setting up listeners and handlers, right? And so the simplest one is a listener for when the user clicks the button. But you can also listen for whether another part of the application adds a new feature. If you're working like something like Gmail, and it kind of reformats the page when you open a message. Other parts of the application can listen for changes in the model, and we wanted to do that kind of an idea here. So you have a namespace tree, and you set up handlers to listen. So here's our code sample in Python. So you import the namespace object, and then you import a specific handler for that namespace. And so we need to create a face so it knows how to talk to the network. So we have the sample server set up at Memoria. And then you create a namespace node. And this is going to be really simple. It's going to be a tree with starting with one top-level node. It can be a long name, right? That's the prefix we're interested in. And so we create a namespace node with that name. And we tell it to use that face to communicate. Then down here, this is going to be a segmented object. So this is a web page here, which has been segmented: segment 0, segment 1, segment 2. And so we say under this namespace prefix, we want to use a segmented object handler. And so we take that node and we attach that handler. And so from then on, the common name library is going to treat that in the child objects, which are segments, and know how to handle them. I'm going to give a callback here, which is a very simple callback, which is when the common name library, by whatever means, believes that it's assembled all the segments, it's going to combine them together into the full web page and give me this callback, and I can do what I want with it. Here we just print hello. And then to get it going, I call object needed, and I'll explain a little bit more about what that is. The idea of unifying the approach is to get away from this hard distinction between being a producer and a consumer. And a classic example was in Peter's conference application. We have a chat room, and I might have been a consumer and retrieved somebody else's chat messages, but now they're offline. And so if somehow an interest for their chat message could get to me, then now I'm a producer. And so we wanted to make it easy for the application to not have to care about that. and so so the way it's this higher level concept, which is you just simply say there's an object needed, and the object could be either produced by me, or it can be satisfied by me asking the network for the object. And so we generalize that. The idea is that we have this unified state diagram where you start from needing an object. You can either take the producer path or the consumer path. In either way, you end up with the answer, which is I have the object, however you got it. And you can imagine each as as you move through each of these states, you can have listeners, and the application can listen for when each of these is achieved. I've reached a state where I simply got a packet, for example. I've reached a state where I not only have the packet, but it's been verified. Maybe you want to care about one or the other steps. So for the next steps, you can imagine you can attach persistent storage for this. So behind the scenes, it'll take care of keeping track of the data. We want to experiment with a new psync protocol, which I think you'll hear about more later, as a way for everybody to form their common picture of the namespace. We are using it for part of the AR application right now. We want to try more. And also, now we have this general framework. You can attach more protocols to it, including the real-time data retrieval. And when you have the slides, you can use these. Here's how to learn more about name-based access control and NDN cert that Alex talked about, and here's the code for the common name libraries that we now have in a few languages.
So the setting handlers were the place where data is produced and named and signed and made available. So it's really kind of reactive model.
Yes.
Did you find any proactive publisher interface in the libraries where the producer can put things into the persistent storage, and independent whether there is an interest or not, it is there. And later, 5 days later, there could be an interest coming.
Absolutely, and that's the idea. Is the simple idea of a producer is interest comes in, the library is told about the interest, and then the producer creates it, and then you actually attach the data to one of the nodes, and you can do that ahead of time.
My question is, do you have a proactive production?
Yes, absolutely. You can. It's the same one that's used when you produce it. It's called set data. Where the node namespace node, you call set data. You can either do that in reaction to an interest that came in, or you can do it ahead of time. And then all those would be there. And then later, if the library gets the interest, it already has the data packet to send out.
I need to know the name for the set data thing. How get I the name to have the right name for evoking that set data, set object thing?
Well, that would be the idea. If like you're producing video frames, you kind of know what the names of the frame number and will be. So you kind of know ahead of time, and you just stick it into the namespace tree. You attach the data packet to the node, and the producer knows the name, and so it's going to do that ahead of time. Good.
Really, the write that we can do with that set object is called write. So how I can write to the memory fabric that NDN is serving.
Yes, you can proactively write to the namespace.
Okay.
Christian, one subtlety that might be of interest is that the intention is that prefixes and packets could be treated kind of analogously. So if you have a multi-packet data object, you would deal with the prefix and write the data into that prefix in the memory, and then depending on the type of handlers attached, or if you want to think of it in an object-oriented way, the class of the object, the underlying names would be created and filled. So the idea is to be able to kind of work at the packet level if necessary, or work at an object level that corresponds to prefixes in either proactive or reactive.